Good morning, Year 10, it's Mr. Sun here. Now today, rather than doing our usual Wednesday drawing task, what I've decided to do is have a look at some of the sort of basic hand tools that you really need to understand and some of the principles behind them. Now we're going to start out with, because we've got a number of these ones, as you can see across the surface here. What I'm going to ask you to do is listen to this video and then go off and create your own little list of them with an image and then a description beside it of what it's like and what it actually does. So you're going to be doing the same thing that you've done with a number of different tools already in the past. But there's some key concepts that I also want you to grasp, to understand. We've got in front of us at the moment an engineer square. Now, an engineer square is very similar to, woodworking or carpentry square or tri-square. And often students will say, well, why can't I use an engineer square on wood and also a carpenter square on metal? Well, technically there's no reason why you can't, and in fact people do. But the thing with an engineer square is it's usually higher accuracy. It is machined and it is placed very specifically at 90 degrees. You can see here that as well an engineer square tends to be made out completely from some sort of metal, usually high grade steel or machined metal, and it usually has these key bits. So you've got this piece coming down here and this piece that's just going along there. There's the bit at the top is called the stock, and this is actually called the blade. So for those people that like to pretend that things are weapons, this is exactly what this one is. It's the blade, because it's thin, it's made out of metal, and this is usually the bit that you are going to mark up against. This bit goes up against the material you are going to actually have a look at. Now, you probably say, well, do you use that in conjunction with a pencil? And again, you can do, but the big problem with doing that in engineering terms is that pencil and metal don't mix very well. You don't get a very good, especially if it's a very fine surface, a very polished surface, your pencil is just going to rub off very, very easily. So what we tend to use is we use scribers or a scribe. Now, these are the second one that I want you to have a look at, and they go hand in hand with the idea of marking out metal. Now, a scribe, and we've got some different ones just here, can be very, very simple indeed. It can literally be, as you can see on this one, it's a bit of tool steel that has been machined down on a central lathe. It's usually got knurling on here, which is that kind of pattern to give you a bit of a grip, and it comes to a fine point at one end. And that fine point is used to scratch into the metal. Now, that does often seem a little bit strange to students that you would deliberately scratch the metal, but it's the best way of marking things out and making sure that you can see your marks later when you're going to machine. Now, I've got this lovely video, and I will link to this one, where the guy is talking about how he's got a piece of metal, so he's got a bit of stop metal just here. In fact, I'll mute him. And what he's done here is he's got a nice straight edge, 90 degree there, and what he wants to do is he wants to mark a line across. Notice he's actually put a bluing compound on the top. The reason for that is, again, that helps to show the scribe mark, because it can be quite difficult, especially if you're trying to film something, to see the contrast between where you've actually scribed out your details with the scribe scratched in the surface and the surrounding metal. So you see he's using an engineer square just here, and he's got quite a bit more of a fancy pen style scribe just there, and you can see that he's placing the stock up against that right angle edge, and then you've got, and you can see he's talking about it there, and then you've got this bit, the blade, which comes in. Now, as you can see, you want to keep it nice and tight up against the body of the metal, and then you take your scribe, and this is when you run it along the top edge nice and carefully, and it should be kept to a really good sharp point so you don't have to place down too much pressure, and you just use it like a pencil or a pen and you put in the mark. So if we can watch him now just go down it in one motion, a little bit of pressure on there that he's doing, because obviously this is quite tough steel. I imagine he's probably using tool steel on this particular one, and then he takes it off. Now that is marking out. So you can see there that it has gone through to the surface and it is scratched into that. And the blue helps us to see exactly what he's doing there. So that would be your guide for those marking out. And that's what we mean when we say marking out. Now, so we know what an engineer square is. We know what a scribe tool does, and by the way, we can get those in various different styles as well. So you can get loads and different ones. They can have different types of angles on them, but the simplest one that you usually will know about is the very, very simplest standard steel scribe looking like that, and these are the types of things that we have in the workshop. Now, the next thing that you might see is something called a surface gauge. Now, these really do look quite weird. They are strange looking objects generally. I've got this one here and I'll talk about that in a moment. We've got this image over on the right hand side because these are set up. They have a nice heavy base, as you can see on this one. This is the piece of material that in this particular instance we're actually trying to check. And you can see there's an arm that goes up like that and another arm that comes down. This one's got a dial on it. They don't always have dials. Sometimes they do, sometimes they don't. The simplest ones like this one here don't have any at all. And what it allows you to do is it's seeing if this surface is flat. So surface gauge is what you use, A, for marking out parallel lines. So you can use this to run down the surface and actually mark out parallel lines to the edge. Or it allows you to test if a piece of metal is actually completely and utterly flat, because you can run it up and down and this gauge shouldn't move too much. In other words, there's not that many imperfections on the surface. So as you run it up and down, the needle will not move up and down too much, if at all. And that means that you can check that a surface, say for an engine block, is really perfectly flat and clean. So surface gauge, it does come in a little bit more complicated as you go on, but really that's what. So the two main things are for marking out in a similar way, because it's got a sharp point on it, for marking out surfaces, so you can see the sharp points there and there, parallel lines, usually got a magnetic heavy base as well, and it's also used for checking a surface. Next tool we're going to have a look at are dividers. Now these are instantaneously recognisable and look very, very similar to what you would think of as a compass. And it kind of is, it's like the metal part doubled up on a compass. You've got this side just here, and then you've got another one. Now, knowing what we do know about marking out, you should be able to tell me why it's got two metal bits and no place for the pencil, because of course, as we've already discussed, you cannot, or it is not good practice to use pencil to mark out metal. So in this instance, these are used for creating arcs or circles and marking them out onto a piece of work that you're doing, but it uses the scribing style of a sharp tip to make that particular mark on the surface rather than a pencil. It can also, because this little arm just here can be moved in and out, and it can be used to check distances on things. So you can use these to check distances as well. So you can set it to a particular sort of length and check that things are all the same distance apart. So it does have many little uses as well, and it's something that we often will use in the workshop quite a bit. Moving on, we've got something like this. This is called a Vblock. Now, a Vblock is a very, very simple item, but it is very, very useful in engineering terms. I think we've all had a little bit of a go at trying to drill stock that's cylindrical. So, you've got this circular cylinder of metal, and if we wanted to drill down into this, if you put it into a normal pillar drill on the base, because it's a cylinder, it will roll around really easily. What a Vblock actually does is it means that you can hold that item, because the V itself will hold just about any size of cylinder without too many problems. And this clamp comes down and just affixes onto the surface. Sometimes you put a pad in there so it doesn't damage the surface as well. And that allows you to then hold this in a vise, and you can see that this bit here, these little clamps, allow it to move back and forth parallel to there, and you can have more of these clamps, like almost like a G clamp on the top, to hold them in position. So that's a V-block, and it's really useful because it also holds it at 90 degrees, so you know that this is nice and flat, and even when you're drilling the hole, you're going at 90 degrees to the surface, and that means that's a really good way of making sure everything is very accurate, because without something like this, it's very, very hard to drill or shape or mark out anything that's a cylinder like that. The next one that some students tend to get a little bit confused by is this. Now, this does look like a scribe, but it's not a scribe, it's something that we call a center punch. Now, we have used these because what they're used for, when you're marking out something, say if we have this V-block just here, and if we wanted to drill down at the top here, we measure it exactly down, and it's at 90 degrees to the center origin of the cylinder, it's going to be quite difficult to bring the drill bit down onto that surface and have it actually go in exactly right in the right point, because it will dance around the surface. When you're trying to drill something, it will try to like wander around until it gets purchased, it cuts into the surface. So a center punch, as its name suggests, is actually a punch, something you hit with a hammer that leaves a little indentation, a little mark in the surface of what you are going to be using. And it allows you to drill down into it. So you can do the center punch. You've got this dot punch as well, which is slightly former. So you use that. That's going to be the center point of where you want to drill. You just punch it down. And a couple of taps with a hammer allows that to create a nice little dent in the material that you're creating. And it means that when you go onto the pillar drill, it doesn't dance all over the place. And they come in a variety of different ways, but they are pretty much the same type of thing. They are a piece of hardened tool steel that comes down to a nice, really fine point. And again, like the Scribe, they need to be kept sharp so that they can do their job. If this becomes too rounded, obviously it's not going to do as good a job. But you'll notice that the point is at more of an acute angle than you have with the Scribe, because it's not really there for use to mark out and drawing of things. Now, the hammer that you would normally use to actually hit the center punch is going to be something like this. It's a ball peen hammer. Now, I deliberately brought up a claw hammer because a claw hammer is different, because it's got a claw on the other end. Now, we don't tend to use these in engineering terms because this claw just here is used to get nails out. This really is a hammer that's designed to hit nails into a piece of wood. You've got this flat surface just here, the handle obviously you hold, you've got a nice amount of weight, and it's perfect for putting nails in. If you need to get the nail out, you use this bit to make as a mechanical lever to bring them out, and that's why the claw, as it's called, just there is at an angle, allowing you to do just that. And you can see that the head of the nail can slip down into this V slot and allows you to pull them out. But the ball peen hammer doesn't have that. It has a ball. So you've got the same kind of head on one side, and then you've got this just here. Now this, obviously that side of the head is perfect for using with a center punch or other bits and pieces like that to just tap down. So that's why we use it usually in the engineering workshop. The ball peen one, the ball peen hammer, this part just here, is rounded and domed and can be used to form metal. So it can be used to heat up, to form metal, to shape it, to make it, indent it so that it has a dome or it has like a valley placed into it. Now, these are often used with kind of silversmithing, and you do get more of them and blacksmithing. And we don't tend to use that as much, but it does have a place in the workshop just purely because it's a very, very useful weight to have and to use with the center punches. So those are the basic kind of tools, hand tools for marking out metal, really, and for helping you to actually drill and set those up. What I'd like you to do is, for every single one of those, you can leave the claw hammer off, but it might be useful for you to just put that one in so you remind it, and just use this video and what I've discussed, as well as your own research, and maybe the actual textbook as well if you have one, to just record those. Do it in a Word or in PowerPoint, and as usual, if you could print those out and get those into your books so that you've got them for future reference. Thanks everyone. Hopefully that's nice and clear, and I will speak to you all soon.